Thank you for the good opportunity to talk with you, farmers and dignitaries, as well as some industry person in agriculture. Today's I will address the new subject, that is applications of artificial intelligence in agriculture. As and when I started my career in 2003, when we are there for marketing some micronutrient product for in all over in Maharashtra. After that, we are working with. I was working with some seed companies, and now I am associated with a Khetibuddy, which is a unified agtech platform, which is where we are doing some softwares for agriculture and data management, farm management, such type of activities through our Khetibuddy platform. So nowadays, when started in 2003, there was no any awareness about the data and the crop yield and some other artificial tools for the helping the farmer, as well as some decision support tools for farmer. But nowadays, lots of happening in going on in agriculture through artificial intelligence, through data management, through agtech platform. So comparing 2003 and 2023, we are very much strong enough to digitize our data as well as some identify what's going on our field. So such type of applications are helping us farmer in a different way for the increasing yield, controlling plant population, control many ways. This type of intelligence, artificial intelligence, can help in agriculture. So I would like to give for another 30 minutes for your for this learning, and some I will share my views about this artificial intelligence. And we are happy to your questions, answer your questions, and some questions will be the most delightful and most insightful. Me also, my this is I think my fourth or fifth addressing to your this tech platform. So I would start with my objectives of this today's seminar. Today's webinar is overview of agriculture, overview of artificial intelligence in agriculture. I want to deep dive into a specific application. There are some specific applications I have taking here help to help the farmer as well as some industry person. And what is the future scope of AI in agriculture? These are the three objects of today's my 40 minutes webinar. What is AI in agriculture? It is a basic question. I will answering many with many farmers as well as some industry people also. There is a use of advanced computer systems. There is algorithms, defined algorithms. We do data analytics, and some sensors. What is AI in agriculture? AI in agriculture use computer systems, set algorithms, have data analytics, and some sensors to gather and analyze agriculture data for making predictions. Some predictions are making by this analysis and gathering of the data, and providing some actionable insights to farmers and stakeholders in agriculture industry to increase productivity, efficiency, and sustainability in agriculture. This is a simple definition of AI in agriculture. I would like to answer these questions. What is AI in agriculture? This is the AI in agriculture. Use of computer systems, algorithms, data analytics, and sensors to gather, analyze agriculture data for making predictions, providing actionable insights to farmers and stakeholders in agriculture industry to increase productivity, efficiency, and sustainability in agriculture. This is the in short definition of this AI in agriculture. Then, what is AI in agriculture? That is, what is detection and monitoring? What systems of AI? There are some detection and monitoring. There is a prediction and estimation. There is intelligence and automations. In this way, there are the broad four categories. There are many categories in AI, but as per as our concern, as per as agriculture, we are focusing on detection and monitoring. Some pest detection, insect pest detection, then nutrient deficiency detection, soil quality detection, soil nutrient detection, and some after detection we go to for monitoring. Then prediction, what is the yield prediction, yield estimation, then disease pest of occurrence estimation. Then there is a major, that is a weather forecast, weather data estimation. Such type of we are doing this. Then intelligence, what will be the next step? What will be the next activity? What will be the next insightful decision? We can judge with through AI. Then automation. Then what will be the done by a system through automation. Such type of algorithms, such type of case studies are going on in our agriculture. Next, these are here some models are going on. That is a detection and monitoring. What is AI in agriculture? That is detection and monitoring. This module. This module help. First, there is a crop is going on here. We are here all over. What is the area of this crop growing area? Then this is the crops. This is satellite. The satellite get data from the field and detect what will the and classify their data, detect and classify their data. Then pest detection. It is a, if you click the picture of the disease pest, whatever you are seeing in your farm, you are in orchard, you are in, you can just click the picture and send to the system. System will say what will the possible questions, possible answer for that question. Then smart, there are soil and weather monitoring system. There are many companies are working in this type of soil and weather monitoring systems. Then prediction of crop yield, that is what will be the sugarcane yield, what will be the turmeric yield, what will be the soybean yield, what will be the maize yield. Depend on the data and average yield, we can get the prediction of data. Then prediction of weather, what will the weather conditions as per today's condition, what will the 15 days, 7 days, or 1 month, or whole year data can be prediction with data analytics. And at the same time, prediction of disease and pest infection also we can monitor through our AI systems. Then field productivity zones, we can zone the zoning can be done, that can be done with field productivity. What will the data we have captured last 4 year, 10 year, 20 years, what will be the yield of that plot? We can analyze the data and predict our productivity zone. What will the next year this will product for as per the crop situation. Then agriculture market intelligence. There are numbers of crops are going, and there are many seasons are in agriculture. So whatever with the possible rate to our commodity will be the agriculture market intelligence through our data analytics can be happening through data analysis. Then farm activities tracking and decision support. This is the main insightful actionable item to the farmer. What can we do activities and tracking their activities through our decision support system, that is AI system. Then smart irrigation and nutrient management based on data, based on cropping systems, and based on nutrient availability in the soil, we can direct do the proper methods to apply the nutrient to the farm, apply nutrient to our crop through last year data, last 10 year data, last 15 year data. We can manage our plots through this smart irrigation and nutrient management systems. Then we can employ robots in agriculture through this system by giving some command, by giving some decision supports to these robots. They can harvest, they can plant, they can prune, they can do our activity as per our requirement. This is a robotics in agriculture. So in broad way, these small these are the major ways through a farmer or through our agriculture industry can do a lot through AI in agriculture. So this type of studies, this type of whatever was the requirement of the farmer, what will the requirement of industry, we can to pick that module and go with that module and deep dive in the system. So this type of structure, this type of AI models, though robotics are the module, smart nutrient and irrigation management are module, tracking, field tracking, activity tracking and decision support mechanism is there. Agriculture market intelligence can be happening through AI. Then field productivity zones can be employed. Then prediction of weather. Then disease prediction of pest and disease. Then prediction of crop yield, crop rotation and classification, pest and disease detection, and some smart soil and weather monitoring system. So there are around nine to ten systems are there. Through our modules we can help the farmer as well as agriculture industry through AI in agriculture as far as Khetibuddy is concerning. So this is a small case study based on NDY data, that is a normalized satellite image data. We can get what will the possible cropping pattern in that area. This is the map of the map of the plot. So having that, there are many crops are growing in this data, this field. There are wheat is growing on there, maize is growing on there, rice is growing in there, sunflower is there. There are dense forest is there, or some of unclassified data and cropping pattern is there. So what is the area of that field? What is the through this picture we can judge that is a here is a wheat, yellow segment showing a wheat area, light green segment showing that it's a maize area, pinkish area showing it is a rice area, red zone determining that it is a sunflower area, dark green shows it's a forest area, and light blue this is shows it may be a river or it may be an unclassified area where we can take that this through this picture we can various area can be mapped through AI system, that is a NDY data, that is satellite image data, that is a normalized deviation in index. We can get data and analyze our what will the index from that area, what will the wheat, what will be the maize, what will the rice. Many crops are there. What can be the cropping pattern is there. We can judge that is the based on the algorithms. We can fix that it is a wheat or any crops are there. This is make one case study. This is a second case study of the computer vision through our AI data. It is a turmeric plot. There are in Maharashtra we are growing many around Hingoli, then Parvani, Sangli, Satara. There are 4 to 5 districts are there who are growing, which are where turmeric is growing a lot. So there we have plot our system in turmeric plot in turmeric farmers. There we are diagnosing that is a leaf blight through our computer vision, that is AI system. So in a picture, in first picture, this is a plant picture, that is a in field there is a disease, infection of disease. It's a leaf blight caused by Taphina fungus. So this type of fungus can be identified by the computer vision. So in second picture, it will take, there is a red marking is there. It combined with their own data in system data, where we have uploaded around 1,000 to 5,000 images through learning to learn the system. Then after learning, it can show that it's a 95% leaf blight and the other may be a 5%. So if system is saying it is a leaf blight, after studying, after getting that data, after learning, so it is a main classification, classified example of the case study, that is a identification of disease. It is it's a 95% leaf blight. And if leaf blight is system, if there is a leaf blight, our system can diagnose. Then we can advise the farmer through our decision support, our through this system. It is a leaf blight. To control the leaf blight, we go with the some preventive measure or curative measures. There may be chemical pesticide there may be biological pesticide, there may be a nutrition support. So such type of applications we can develop through the computer vision. Then it's a estimation and mapping of soil organic carbon through AI system algorithm. Say at the same time, through we can again it is a map of the field, map of the area, and through this area we can judge either it's a dark dark brownish area is there. Dark brownish area it shows more than 200 SOC gram per kg. Then light blue color, light blue color shows that it's a 0 to 10 gram per kg of organic soil organic carbon. It is very depicted. From the seeing this image, there are very small area. This is the high organic carbon area. This is a high organic carbon area. This is a somewhat high organic area. This is a good area. But this area where is a majority of yellowish patches are there, which are shows it's a depleted SOC and soil organic carbons are very low in this area, around less than 10 gram per kg. It's a 0.1% is there. So accordingly, we can guide our system, our farmer, and as well as our some industry people who are wanted to do more with this data. So based on this case study, we can show that what will the organic carbon is there in our area based on the artificial intelligence through satellite imagery. This is again a case study of sugarcane. Here we can predict the data, we can predict the yield of sugarcane through AI/ML algorithm model using satellite data and for multiple seasons. We have grown taking the data of around 2 to 3 years. After that, finalizing the data, there is a free orbital images. Then it's a sugarcane plot is there, crop figure variation is there. Then it's a sugarcane yield after harvest. Then integrating data, we can say that it's a red area. A red area which will give around 40 to 50 to 40 to 60 tons per hectare, and that dark red area, dark green area, we can show around 82 plus ton per hectare of the sugarcane yield. So considering this image, satellite image, we can take that what will be the approximate yield, what will be the prediction of the sugarcane yield through our satellite image data. Then again, it's a case study of the remote sensing and IoT device. It's a majorly it's a good business to many farmers are establishing, farmers are installing that the remote sensing for IoT device in their orchard, majorly sugarcane, then grape, and some pomegranate farmers are there who are going with this IoT devices. We are doing with Arable. It's an American-based company, USA-based company. We can get data USA. We can have a module through remote sensing data, which are based on Arable data. Then future trends in agriculture. We can majorly consider that what can we do today? What are our core strength is in this area? But future trends are farm automation is a future trend of the then precision agriculture, advancement in precision agriculture. We are taking decision on based on bags, kilos, but through precision agriculture, we can take decision based on gram or ppm. Then some are there hydroponics and vertical farming. AI can help, and there is some crop breeding facilities. Crop breeding softwares are there through seed companies. We can go with the AI through crop breeding. Then it's a global market scenario. What is the global market scenario of the AI in agriculture market? In North America and APSC, comparing the APSC, it's a fastest growing market in by region to 20 to 2030. This 10-year, the market boom is there. So we can go with this artificial intelligence in agriculture. Market is blooming. So our focus should be giving a proper solution, proper module to farmer as well as what can the new requirement of the industry. So what will be the proper requirement of that industry as well as the requirement of the crop, what will the requirement of the farmers, and based on that, our intelligence data, intelligence format, intelligence algorithm will do a very drastic change and saving money, and it's a very sustainable agriculture. Thank you.
Thank you very much, sir, for a wonderful presentation. I will take up the questions from the participants now. In the meantime, can you please stop sharing the screen, sir, so that we can see your full video? Yes, sir. I'll move on to the questions now. The first question is, what AI technologies are being used to enhance livestock management in the agriculture industry?
Actually, a livestock management in AI, there is a there are grazing area. What do you will the grazing area is there, and through grazing area we can take that where to the grazing. First grazing is first lot of grazing, second lot of grazing, third lot of grazing. So we can manage the area, grazing area through AI. First thing. Second thing, what will be the average milking period of the any cows or buffaloes? We can manage. That is a what is the milking time or milking period? 90 day, 900. 9 months, 8 months, 7 months, 6 months, depending on that area, that duration. We can fix that it's a highly productive breeds of highly productive cows and buffaloes based on the data. Then third point, we can give the artificial intelligence to livestock management. That is a decision support for, that is a vaccination program. Vaccination program, we can manage their vaccination program through our AI systems. Then that is a feeding habits. We can manage their feeding habits and the feeding schedules through AI systems, and based on that requirement, based on their requirement, we can give a better yielding approach to our livestock.
Okay. How does AI assist in predicting and managing weather-related risks for farmers?
Based on that is a forecast, a weather forecast, we can get the data. That is a what will be the next 15 days, next 16 days, what 7 days data. We can predict what will the possible solutions for the suppose there is a heavy rainfall in the area. Suppose there is a heavy temperature hike in the area, then we can today's the live condition here. Suppose in turmeric plot there are blight is there because of in morning after 3 a.m. To till 7 to 7:30 a.m. there is a fog in the environment. So which fog can affect the dew, that is a leaf petiole, leaf wetting, leaf wetness. No, that leaf wetness can contribute to fungal infection. So if we can manage, we can get data from system, that is there is a possibility of fog in the 3 to 7 a.m. We can guide the farmer, that is go for any possible foliar spray, or we can give any chemical spray to control the possible to avoid the loss of the crop. Thank you.
Okay. Are there any AI-based solutions for soil health monitoring and management in agriculture?
Yeah, we have the data for soil health management. through there are many algorithms based on NDY data. They are working on organic carbon, then nitrogen, then phosphorus, then soil pH, and based on the it's a regenerative farming or no-till farming or till farming. Based on that algorithms, we can get a very insightful decision, insightful activities to guide the farmer as well as to guide the industry. We have the algorithms, we have the possible to develop the as per the requirement of the industry.
Okay. How is machine learning being applied to crop recommendation systems for farmers?
Yeah, machine learning system. Suppose in their NDY data, it is a satellite image data. It's artificial intelligence. If farmers have mapped their field in our system, then the satellite moves around the field. It gives images to our system. It's maybe by weekly, it may be we are two in the week, it may be a fortnightly, based on the system, based on the requirement or based on the models we have choose. Our model gives two images per week. That is a alternate 4 days. Alternate 4 days images can help our agronomist that during our growth period, this month these for 10 images are very good, showing that is the NDY values 0.56, 0.67, 0.56 to 0.67. It's an ideal growth of the crop or the ideal growth of the turmeric crop. Suppose another this week image showing that it's a depleting NDY, that is from 0.56 to it goes 0.43. This means that is any possible cause, that is it may be a disease or it may be pest infection or it may be a nutrient deficiency or it may be a heavy rainfall or it may be a that is heavy irrigation at that place, at that point of the where they are showing 0.43 NDY values. Suppose such NDY values showing the depleting values can contribute to some problems are there. We can guide the farmer based on this that is the 0.43. So in turmeric we have it's a bell-shaped curve of NDY value from 0.000 to 1 based on just like it's a crop establishment stage, then it's a till stage, then it's a vegetative growing stage, then it's a rhizome development stage, it's a rhizome maturity stage, and after and harvest stage. So during this stage, crop moves from 0.0 to 1. It's a going upward, and then it goes downward. It's showing a bell-shaped curve. So till rhizome development, crop should be in 0.67 NDY values. 67 NDY values. Depleting in these values, we can guide the farmer through our whether through our system, through notification goes to farmer and some message goes to farmer, that is a your NDY value is going in depleting through point some values to another values. So we can guide the farmer through advisory. We can give a nutrient spray. We can give a foliar application of nutrients. We can give a spray solution for insecticide. We can give a spray solution for biopesticide. What will the possible solution, possible requirement of the crop through AI system? Thank you.
Okay. What are some examples of autonomous agricultural machinery and robots that use AI for various farming tasks?
Presently in India, it's a niche market is there majorly, but AI can do a lot through system. Suppose it's a robot. Suppose you are a grape growing farmer, and we have the weeds in the field. So pruning that is a leaf cutting machinery is there. The leaf cutting robot is there. It can goes through our lines, that is a that is a what is it called? That is main line through the robotic goes through to a line and cut the, that is the weed growing in the field. So such type of robots can be work in the system.
Okay.
As far as India concerned, it's a niche market, totally not going very rapidly. But in American, USA, Canada, California, we have we can have some robots for pruning, some robots for weed manuring, some robots for bed making robots are there, some robots are spraying is there, and in particularly in Maharashtra, we have drone. The drone are very growing. Many farmers as well as many FPOs are have bought the drones for spraying, and togetherly they are working for spraying, mainly spraying of pesticide or spraying of nutrients on sugarcane, on grape. They are doing very wonderful work in the through FPOs, many farmer groups, farmer organizations, and some farmer support is there. Government support is there to the farmers.
Okay. Could you explain the impact of AI in supply chain management for agricultural products?
As per a supply chain, we have not just not in good doing well in supply chain, but we are in crop management. As per as crop management, pre-harvest we have done a lot. Post-harvest we are working, not a considerable work we have done, but we are working on that post-harvest. But we have a lot of in pre-harvest.
Okay, move on to the next question, sir. Just give me a minute. How does AI contribute to sustainable and environmentally friendly farming practices?
Yeah, it's a very big question. Good question. That is how AI will support the sustainable and sustainability agriculture. In many areas, we are doing. Suppose we are going grape cultivation, and we have schedule. We have to go for this spray, this spray, this spray, this spray. Do a daily, alternate day. Some are going continuous spray is schedule is there to spraying of the schedule. Whatever the crop condition, requirement of the crop, detail considering, not considering such type of questions, but they are doing spraying as per their schedules. If we are employ AI system is there, suppose we have installed some IoT device, we have some that's the employed or that crop area through NDY, we are monitoring crop area through NDY. That NDY value will say it's a crop condition is good not to spray. IoT device will say it's a leaf wetness is this, and possible disease infection will be the that days. So some days are very critical, and some days are not too much carry on go for that spray. So we can minimize our spray concentration. We can minimize our spray schedules. So we can minimize our requirement of that crop based on this AI system. So we can minimize our cost. We can minimize our that is carbon emission through pesticide, carbon emission through that is a sprayer or blower are going in the moving in the field. So suppose we have cut down sprays, they are around 40 to 60 sprays are going in the field, that is grape field. If we cut down through a 10 sprays or 20 sprays, we have we have make a lot of change in the cost, in carbon footprint, and in sustainable agriculture. Thank you.
Okay. What are the challenges and limitations of implementing AI in agriculture, and how can they be addressed?
Major challenge is its awareness. Awareness is less awareness in the field, and the second challenge is the trust. Farmers not trusting the technology very easily, but in some area where we are working, particularly in turmeric crop, our farmers are waiting for our NDY graphs, NDY maps. So such type of farmers are awareness creating activities through our agronomy team and our field team doing a lot to make the awareness of these AI systems in farmer. So after they have trust with us, and now they are blindly follows whatever with our solution based on the AI values, AI NDI values, and the AI system.
Okay. In terms of data privacy and security, what measures are in place to protect the sensitive information generated and utilized by AI system in agriculture?
It's a cloud-based system totally, and it's a system. Is a very that is a we can do a lot with system. Our system, what will be the data privacy is there. So legal data privacy, all measures are concerned, taken care to before in our agreement we have done such activities.
Are there AI applications for monitoring and managing irrigation system in agriculture?
Yeah, there are sensor based as well as the NDMI, that is a normalized deviations in moisture index. So such type of NDMI can help in moisture management, that is the soil moisture management in agriculture.
Okay. How can small scale and resource constrained farmers benefit from AI applications in agriculture?
Sorry.
I repeat it, sir, once again.
Research concern, I
repeat it once again, sir. How can small scale and resource constrained farmers benefit from AI applications in agriculture?
Yeah. Resource consent is a small farmer. This is, you are talking about a small farmer.
Yes, sir.
Yeah, small farmers are in the system. They have cut down their cost on. They are blindly follow what will the next what the neighboring farmers are doing. But based on AI, small farmer can approach the system. It's just like mobile application in their farmer in their mobile app. So it's a small application. We can download the application and get the map your farm data, map your farm, then map your crop is there, and what will the data probable date of sowing, what will be the based on that soil, based on your values, cropping pattern. It can be a the crop should will be the in the system, and based on we can a small farmer can adapt this technology through a system.
Okay, thank you very much, sir. We have now completed the round of questions on behalf of agricultureinformation.com. We like to thank Dr. Prakash Mali for the talk and for answering the questions. I'd like to also thank all the participants in the meeting. This meeting will now be closed.
Yeah, thank you for opportunity.
You're most
Thank you for
welcome, sir.
participants. Thank you.
Thank you very much, sir.